Factor the quadratic function d of x equals 64x squared minus 121 using an algebraic method. So the first step is just to look at our function and see if there's any common factor that we can factor out first thing. And so looking at 64 and 121, there's actually no numbers that go into both of those other than 1. And so we can't factor out a number there. And then looking at these, then I see that 64x squared is a perfect square because the square root of this would be 8x. Just, perfect integer there. And so that's a perfect square. And then we also see that 121 is a perfect square of 11. And so knowing those things, then we can see this will be the difference of two squares because they are both perfect squares. And we can then factor it using this formula. A squared minus b squared equals a minus b times a plus b. And so if we want to write 64x squared as a whole term here and then squared, we basically just take the square root of this term. The square root of 64x squared is just 8x. And we see that that squared gives us what we started with. And then b would be the square root of the second term. So the square root of 121 is 11. And then vice versa, 11 squared gives us what we started with. And so we just rewrote it in a different form, and now we know what a is equal to and what b is equal to. It's just these inside terms, and so we can plug them in here on the other side. So a is 8x, and then minus b, which is 11, and then again 8x, but then we have a plus here, the minus on the first one, and then plus 11. And so now we have our factored form, 8x minus 11 times 8x plus 11. So our final answer will be, since d of x is the difference of two squares, it can be rewritten as d of x equals 8x minus 11 times 8x plus 11.